Our project focuses on predicting students' final grade from their drinking habits and discussing the ethical issues that surround using this model. We pulled a dataset created by P. Cortez and A. Silva from UC Irvine's machine learning database. The data had 30 different feature vectors from secondary students taking math and Portuguese. Due to the wide array of variables, we had many options to find correlations between them. However, our most important goal is determining what information, if any, is fair to use to predict a student's success.
Our approach was pretty simple. We found a dataset that correlates social economical factors, alcohol use, and student grades. This dataset had two classes, Portuguese and math, in which that we combined the two classes. We changed the data grade from a scale of 1 to 20 to a pass or fail, or a 0-1, and we changed all the categorical features into numerical features. The next step was to normalize the data by equalizing the number of students who passed and failed and who were light and heavy drinkers. We next used linear regression to train multiple models, one with protected features and one without. The last step was to generate a ROC curve to observe the fairness, and we tried to calculate the best threshold to get the most accurate predictions.
Training our data without the protected features removed, we got an accuracy of 95% for the math class and 88% for the Portuguese class. After we removed the protected features, our accuracy went down to 67% for the math class and 75% for the Portuguese class. This showed us that the protected features allow the model to train more accurately, but the trade-off is that we will lose privacy. We were then able to calculate ROC curves to analyze our results. We found that the algorithm was sexist for the math class, where women were predicted more likely to fail than men. Conclusions like this enforce the stereotype that men are better fit for STEM roles. We were also able to see a bias for alcohol consumption and previous grades, and to our group, we thought that this information should remain private and not be public information for models to train on.
The creation of this model comes with ethical and societal issues. Institutions like colleges can abuse the model's predictions and only admit applicants predicted to do well, in turn increasing their prestige. They would reject those predicted to fail based on private data, ignoring the student's other qualifications. Another issue is the connection between personal and professional life. Is it ethical to invade someone's private lifestyle and make assumptions and decisions that would directly affect their future? The causal relationship between protected attributes and school performance should not be exploited by any institution. In conclusion, our model uses private data from students to predict their final grade. When these protected attributes are eliminated, accuracy decreases and student privacy increases. Our model can be abused, causing ethical issues to arise, or it can be used for good. Some feature vectors, like access to the internet, directly correlate to a student's success. With this information, schools can create programs to provide resources like the internet to improve students' final grades. Overall, it depends on how the model is utilized and what decisions are made from it.